हेलो स्टूडेंट्स, वेलकम टू एस क्लासेस। आज हम आगे वीडियो थर्ड प्लस टू के लिए डालने का प्रयास कर रहे हैं और ये लेक्चर 3 होगा प्लस टू का। कल हमने 10th क्लास का एक वीडियो डाला जिसमें हमने लेक्चर 1 और चैप्टर 1 रियल नंबर्स, तो उसमें अच्छे रेस्पॉन्स आ रहे हैं। बच्चों ने काफ़ी लाइक किया, सब्सक्राइब किया, बहुत अच्छा रेस्पॉन्स मिल रहा है। इसी तरह से आपका रेस्पॉन्स मिलता रहेगा तो मुझे भी एक प्रोत्साहन मिलता रहेगा और मैं भी आपको 10th क्लास, प्लस 2 क्लास एंड प्लस 1 क्लास cbse रिलेटेड सिलेबस से चैप्टर वाइज लेक्चर वीडियो डालता रहूँगा। मेरा ये प्रयास है कि इस तरह से अगर आप लोगों का सहयोग मिलता रहा तो ये कंटिन्यूटी बनी रहेगी और इसमें हम सफल हो जाएंगे। मैं आपको एक और बात बता रहा हूँ कि जो स्टूडेंट्स नहीं देख पाए वो आज मैं इस वीडियो में जो प्लस 2 की वीडियो लेक्चर 3 की बना रहे हैं, इसमें मैं उसका डिस्क्रिप्शन में उसका लिंक भेज रहा हूँ। आज शाम तक भेज दूँगा, तो कुछ शेयर्स करें आपस में, एक दूसरे को लिंक भेजें। 10th क्लास, प्लस 2 क्लास, आपके सिस्टर, ब्रदर और रिलेटिव जो भी हैं सबको आप शेयर करें। मेरा यही प्रयास है कि ये मेरा वीडियो सब स्टूडेंट्स के पास पहुंच जाए जो कि कहीं ट्यूशन नहीं जा पाते, घर में बैठे हुए ही वीडियो के ज़रिए अपना जो कंसेप्ट है वो क्लियर कर सकते हैं और घर में अपनी स्टडी अच्छी कर सकते हैं। ओके, नाउ टुडे प्लस 2 रिलेशन एंड फंक्शन कंटिन्यूटी वी हैव डिस्कस्ड इन द फंक्शन इक्विवेलेंस in relation, in function and relation. In relation we have discussed the equivalence relation. After equivalence relation, one point I told in the end, equivalence class also in the last lecture 2. Equivalence class I want to repeat here. Equivalence class is the set of all related element with any one fixed element A. As A comma B, many ordered pairs are there in any relation. So for any individual A, B may be many. So equivalence class of any one element A is equal to the set of all related element with A to satisfy the relation. Understand this? Okay? ठीक है, okay, I think you understood that. Now, हाँ, मुझे लगता है कि आपकी समझ में ये इक्विवेलेंस क्लास आ गई होगी। इक्विवेलेंस क्लास का मतलब यही हो गया कि रिलेटेड एलिमेंट्स का सेट, वन एलिमेंट रिलेटेड टू द मैनी एलिमेंट्स, बी में बी मैनी विद इंडिविजुअल एनी वन ए। तो विद इंडिविजुअल एनी वन ए, हाउ मैनी बी आर पॉसिबल? दैट ऑल बी, द सेट ऑफ ऑल द बी possible with A is called the equivalence class of A. A is any example for any question, equivalence class of 0. So related with 0, how many other elements are there? The set of all other elements which are related to 0 to satisfy the relation which is given in that question. So that the set of all the possible related element with the 0 is called the equivalence class of 0. Okay, now come on the point today on this lecture 3 forward. One question we are taking more. If check CHEC check relation R check relation R in all lines in a plane defined by R is equal L1 L2 such that L1 perpendicular to L2 for every L1 comma L2 belongs to set A. If A is the set of all the lines in a plane, if A is the set of all lines in a plane, so then L1 L2 belongs to set A, means all lines in a plane. But here condition perpendicular line. So check first is reflexive. So for reflexive L1 comma L1 belongs to R for every L1 L2 for every L1 belongs to set A. Every line, so itself line L1 with L1 condition perpendicularity. So same line with same line will be parallel or not? Same line with same line, coincident line will be perpendicular or not? No, yes, correct. Now it means this implies L1 perpendicular to L1, not possible. Same line perpendicular to the same line, not possible. So false. It means R is not reflexive, sorry. R is not reflexive. Now second, symmetric. For the symmetric, we have if line L1 comma L2 belongs to relation R, this implies L2 comma L1 also belongs to R. Reverse the order, belongs to R. Check it. This implies if L1 L2 belongs to R means L1 perpendicular to L2. This implies L2 perpendicular to L1. Any line L1, other line L2, L1 perpendicular on L2, then L2 also perpendicular on L1, L1 perpendicular on L2, so vice versa is possible. So this is true. This is true. So L2 comma L1 belongs to R for every L1 L2, for every L1 L2 belongs to our set A. So it is symmetric. So it is symmetric. So 2 over reflexive, symmetric, but reflexive, not reflexive. Symmetric, yes, symmetric. Now check the transitive. Third, for the transitive, we have L1 comma L2. For transitive, third, for transitive, if L1 comma L2 belongs to R and L2 comma L3 belongs to R, this implies L1 comma L3 belongs to R for every L1 comma L2 comma L3 belongs to set A. Okay, now you check this. L1 comma L2 belongs to R means L1 perpendicular to L2. This condition will be verified because it is given and this given, and L2 comma L3 belongs to R means L2 perpendicular to L3. Okay? Then implies from both, if line L1 perpendicular to L2, L1, L2, and L2 perpendicular to L3, L2 perpendicular to L3, L2 line perpendicular to L3. Then what is the relation between L1 and L3? L1 and L3 will be parallel. So means this implies L1 parallel to L3. Means this implies L1 is not perpendicular to L3. See with figure. Okay? It is clear that it is not transitive. Hence it is not transitive. Is not perpendicular to L3. Hence it is not transitive. Therefore R is not equivalence relation. Is not equivalence relation. Okay, now we have to go for the next one question more. Generally only I will discuss that question. I will not write fully. You can tell me, because it is general related to that. If relation R such that all triangles in a plane R said that all triangle in a plane, yeah, are in all triangles in a plane defined by R is equal to triangle 1, triangle 2, such that triangle 1 congruent. What is condition? Congruent. Two triangles are congruent. Ordered pair, congruent triangles. For every T1, T2 belongs to set A. Set A means all the triangle set is A. Okay. Now after that, it is clear that first you tell T1, T1 same triangle A, A belongs to R. So it is reflexive or not? Same triangle with same triangle congruent or not? Yes, congruent. So it means done reflexive. So it is reflexive. Okay. Reflexive. Second, check second. L1, L2 belongs to R. Okay, means L1 congruent L2 implies that reverse L2 congruent L1 or not? Yes, because if one triangle congruent to second triangle, then we can say second triangle congruent to one. Vice versa true. So symmetric also. Symmetric also. Now third, if L, yes, now T1 congruent to T2 and T2 congruent to T3, then implies that if one triangle congruent to second, second congruent to the third, then it is automatically we can say that first triangle will be congruent to the third triangle. So then after that T1, this implies T1, T3 belongs to R, means this ordered pair belongs to our relation R. Hence this is transitive. Hence R is transitive. So means for the congruency, reflexive also, symmetric also and transitive. So it is equivalence relation. Okay, therefore we can say R is equivalence relation. Now forward, if more example in this for the similar, if the same triangles set but defined on similar triangles, then if R is defined by triangle such that T1 similar to T2 for every T1, T2 belongs to set A. Okay. Now you see for the first, tell me for the first, same triangle with same, similar or not? Condition is similar. Relation is similar triangles. So same triangle with the same will be similar or not? Yes, because every congruent triangles are similar and that will be congruent, so means similar. Okay, so for the reflexive, it is clear, it is reflexive. Second, check similarity. If one triangle similar to the second, then we can say similar. Triangle 1, if belongs to R, this implies T2, T1 also belongs to R. True. Why? Because if triangle 1 similar to triangle 2, this implies we can say triangle 2 similar to triangle 1. So this implies we can say T2, T1 belongs to R for every T1, T2 belongs to set A. Okay, so it is clear that it will be symmetric also. So symmetric. So R is symmetric. R is symmetric. Now for the third, discuss the third. Direct you can understand how. If T1 comma T2 belongs to R and T2 comma T3 belongs to R, this implies T1 comma T3 belongs to R. Check this condition, means this implies T1 similar to T2 and T2 similar to T3, triangle 1 similar to triangle 2, triangle 2 similar to triangle 3rd. So then we can say directly that T1 similar to T3. This implies, so we can say that T1 comma T3 belongs to relation set for every T1, T2, T3 belongs to set A. Okay, now it is clear that T1 comma T3 belongs to relation R. Hence we can say that it is transitive. So we can say that function is we can say that this relation is equivalence relation in the now. I think for the equivalence relation many questions we have done. So I think that मैं सोच रहा हूँ कि अब ये equivalence relation आपकी समझ में आ गया होगा कि reflexive, symmetric and transitive क्या definition है और किस तरह से हमें इसको एक truthness चेक करनी होती है, एग्जाम्पल नहीं देनी होती है. Generally we have to write, we have to think, general rule and regulation we have to apply according to the given condition, and mathematical tools, mathematical theorem we have to use for make the truthness of the output. So now we have to go forward for the function. Now function, yes, today we are going the clearness of the function definition. Function word is also saying that some work is there. Function, some working is there. Function, output, input, output means if work we are doing something, the output will be there. So every simple machine is a function, basic in the daily life. In the daily life we are using the simple machine. As sugarcane machine, we are taking the juice, sugarcane juice. Okay, simple machine at home. This fan is going on. Fan, this is also machine. This is a function. So every simple machine is a function. Every simple machine is a function where input and output is there. In which machine input is there? What is the input for the fan? What is the input for the fan? Electricity. Okay. Output, air. We are getting the air. So every simple machine is a function. Keep in your mind general definition. Now by the relation we have to check what is the definition of the function, standard definition of the function. If in a relation, every element of the first set has its unique image, has its unique association, has its unique relationship. It means one element associated with the other element, unique. For example, if any relation is 1, 2, then 3, 4, then this 2, 5. If this relation R means uniqueness, one related to 2, one not related to the any other element, 3 related to 4, 3 is not related to any other one. It means unique image. 1 has its image 2, 3 has its image 4, 2 has its image 5. Image means in the function you will see by the pictorial diagram, if here element 1, 3, 2, 1, 2, 3, here 2, 4, 5, 2, 4, 5. If set A, set B. This association from set A to B means R such that from set A to B, if. Okay, so according to this given relation 1, 2, yani 1 associated to 2, 3 associated to 4, 2 associated to 5 means unique association. Here may be left any other element without an association, that is may or may not be. We have to not go on that. We have to see that only unique image only. It means this relation is a function. This relation is a function. Okay, now generally I told you every simple machine is a function. Now one more definition we can say, uniqueness. For example, we can say that if any function is x square, this is the any function x square. Okay, if generally we are thinking what are the inputs, and it is that x belongs to real number. Every real number will be input, x value, input value of x, and output will be value of y. This will be output, this will be input. Input value of x, output out. Function is a machine. This function is a machine. Simple machine. Generally in basic we are using in the daily life many machines. From here we are taking some work. Sugarcane juice machine, cooler, fans, many others, floor, आटा चक्की, ओके। बहुत चीज़ें हमारे लाइफ में हैं जो कि हम सिंपल मशीन देख रहे हैं जिनसे कुछ काम हो रहा है, तो उनमें वो एक फंक्शन है। क्या है वो फंक्शन? उसमें इनपुट क्या है? इनपुट वो फंक्शन है, मशीन है, ये एक मशीन है, फंक्शन है। और इसमें इनपुट वैल्यू ऑफ x इन द मैथमेटिक्स एंड देन आउटपुट value of y. Putting x value will come y. So for every real number x, then y also will be real number. If you see here, so y belongs to which set? Square of real numbers. Square of real numbers. Okay? Square also will be real number. So this also belongs to real number. Okay? So then this is called the here input is called the domain set for the function and output is called the range set for the function. Okay, today we have discussed this. Tomorrow or after day you will get the next lecture, you will get the new video. Okay, now I want to say वन पॉइंट कि आप लोगों का रेस्पॉन्स बहुत अच्छा मिल रहा है। शेयर करो, चैनल को सब्सक्राइब करो और कमेंट बॉक्स में कोई भी आपको डाउट्स हैं उसको ज़रूर लिखें। अच्छी लगे अच्छा लिखें, कोई प्रॉब्लम हो उसको लिखें। मैं प्रयास करूँगा आपके सभी जो भी डाउट्स हैं उनको क्लियर करूँ। ओके, एक और जो मैं आपको कह रहा हूँ कि आज ये वीडियो थर्ड लेक्चर पर अपलोड हो जाएगी। इसके जो डिस्क्रिप्शंस है उसमें मैं पिछले जो लेक्चर 10th क्लास के भी लेक्चर्स दिया है उनका भी मैं लिंक और बाकी पिछले चैप्टर्स जो हुए हैं उनका भी लिंक शेयर कर दूंगा। आप उसको वहाँ से अपने फ्रेंड्स को शेयर करें, अपने आप देखें और चैनल को सब्सक्राइब करें जिससे कि मुझे मोटिवेशन मिलता रहेगा। थैंक यू। Okay.